Hey, my name is Zachary DeMarco, and today I'm going to be explaining the concept of linear regression modeling in the field of engineering, and as you will see later on, specifically in aerospace engineering. So when we model linear regression, we are primarily focused on relating two variables, an independent variable and a dependent variable. We use the equation for linear regression as seen here in order to generate a helpful model showing linear relationships between two variables. We do this by analyzing the intercept, which is represented by A, the slope, which is represented by B, and the standard error, which is represented by E. In doing this, we can create a trend line, which is the red line you see here, or line of best fit to relate the data point. However, there are certain parameters that must be met in order to accomplish this. The main parameter being that we have to avoid having extreme outlier data points and must also be considered continuous, as Tran and Hugh said in 2019. There are two primary types of linear regression that I will be mentioning in this presentation, them being simple linear regression modeling and multiple linear regression modeling. The first slide provides an example of simple linear regression modeling. Um, Here in slide 2, we can see an example of multiple linear regression modeling. The primary difference being that this type of linear regression is uh, we are now attempting to establish a relationship between multiple independent variables as opposed to a single independent variable. Mathematically, this is done by including more x terms in the linear regression equation, as seen as the top of the figure. This type of linear regression is often used in engineering because of practicality purposes, where many times within a system there may be more than one independent variable. We can see how multiple different trend lines can be generated based off of data points associated with independent variables as Van Dam, DeCambro, and Ambrose, Sophie Gray um, in 2015 shows. Generally, multiple linear regression is seen as more accurate than simple linear regression due to the fact that it provides more data on dependent variables. As I said earlier, we're now going to look at the specific case of linear regression modeling used in aerospace engineering in relating multiple different independent variables to a single dependent variable. A study done by Moreno, Oppo, Rubin, and Margalita Antoni in 2017 wanted to uncover relationships between bird strikes, which is when a bird comes in contact with an aircraft during flights or takeoff and landing, and some different environmental factors. As seen in the figure, simple linear regression can be used in this case, but would be more informative and beneficial to use multiple linear regression to model the different environmental factors in which the study was focused. The researchers were primarily focused on bird populations, prey population, altitude, terrain, and time of year or weather. The study ultimately concluded, through the help of linear regression modeling, established a direct relationship between food availability and aircraft incidents, as well as correlation between flying altitudes of some birds and aircraft incidents. This plays an integral role in explaining why linear regression can be such a powerful tool for aerospace engineers and pilots alike, as it will now allow them to adjust flight patterns and establish better safety protocols for aircraft maintenance and equipment. So thank you very much.